Welcome to the Flowtite South Africa, the home of GRP in Sub-Saharan Africa. We are the sole manufacturers of Flowtite GRP and Vectus GRP pipes and fittings. Flowtite is our leading product of water, sewage, and other civil applications. This glass fiber reinforced polyester pipe system offers a cost-effective piping solution. Flowtite pipes and fittings are used for potable water transmission, firefighting, sea and desalinated water, sewer applications, and irrigation. It also has application in power plants and industrial waste. There is almost no limitation for use of Flowtite pipe systems. Please follow me on a tour of our manufacturing facility in Germiston, Gauteng. The raw materials we are using in the manufacturing of GRP are a release film which is applied to seal the mandrel. There is a barrier between the pipe and the mandrel to ensure that the material do not stick to the steel brand. After the release film, we apply the ER veil, and with this, the resin and chopped glass. These will form the inner layer or the corrosion barrier of the pipe. Over the chopped glass, we apply the yarn which keeps the chop in place. We then add 600 Tex glass and 2400 Tex glass, which gives the mechanical strength to the pipe chopped glass. To get the stiffness of the pipe, we use a filler, which is 95% silica sand, which is applied to the core of the pipe. The material we use on our fittings for welding them together is woven roving and chop mat. These are commonly used manufacturing fiberglass swimming pools and truck canopies. Before we use the woven roving, we use a bonding paste to join the parts to fit together to hold them in place while welding material is applied. Depending on the mechanical strength, different sizes will be used. This is the inside of the mandrel, and it is sized according to the current required design specification to be manufactured. It consists of a shaft, discs, and aluminium beams with bearings on the shaft. The steel band, which is 40 mm wide, is then wrapped around the beams to the end of the shaft where we have the return head. The steel band then leaves the mandrel at the return head. Travels to the steel shaft and connects back up to complete the loop on the cam plate. As we can see here, every second beam has a pusher, so as it comes around on the cam plate, it pushes the steel bent forward by the 40 millimeters. That means the manufacturing process is moving 40 millimeters continuously. The glass rovings are placed on the shelves and feed through the combs. Placement is determined by the design specification and needs to be manufactured. For every new design that has to be manufactured, the production supervisor will get a specific file giving all the information for manufacturing the pipe. This includes the setup to actual manufacturing. The machine itself is controlled by the computer and is monitored by our technology department, which is in Norway. If we are not running according to the design specification, they will notify the chief design manager, who will then have a few minutes to rectify the design, or they will shut the machine down. All the manufacturing specification is on the screen and is closely monitored by the team leader on shift. They are a critical process, variable from every 2 hours for quality control. Here, we can see how the raw materials are being added. From the release film, the linear, glass, sand, and resin, right through to the mechanical layer. As the last layer of veil is applied, the manufacturing is finished and moves through the IR heaters, which cures the pipe. This is closely monitored by the infrared camera, which gives us the peak temperature of the cured pipe. Once a 12-meter length of pipe is manufactured, they automatically cut this section of pipe off. The standard length of pipe is 12 meters. We can cut the pipe to suit the required lengths from the client, such as 3 meters or 6 meters. Once the pipe has been cut, it will be visually inspected. And all dimensional checks will be taken and recorded onto the pipe build history document. The pipe will then also be marked with a unique number, the diameter, pressure, stiffness, specification code, length, date of manufacturing. The pipe will also get color code rings on which make it easy for identification regarding the pressure class, stiffness, and if the pipe is COD. If it is found that the OD of the pipe on the ends are slightly higher, it will then be calibrated to the correct size. And the ends are also tapered. This is when pipe moves towards hydro testing. Once the pipe has been calibrated and marked, it arrives at the hydro tester. Here, the pipe is placed on supports and the ends pushed into the molds. The pipe is then filled with water. All our pipes are hydro tested to make sure that it complies to specification. Before pressure is applied, the operator will make sure that there is no air in the pipe. Pressure is then applied and tested to double the pressure rating and kept under pressure for 2 minutes. After the pressure is released, it is then kept at a safe pressure where the pipe is then inspected for any signs of weeping or leaking. This is when pipe moves towards coupling insertion. And pipe is removed from the test rig and moved over to the coupling mounting machine, where coupling is put on at one end of the pipe. After the coupling has been placed on the pipe, the production supervisor will inspect the pipe, and the quality inspector will inspect and release the pipe once all measurements have been confirmed. The supervisor and inspector will spray the pipe with different color spray, which will show the pipe was inspected and released. Flowtite South Africa has a full-fledged fitting shop where we produce any variation of fittings you require from the standard bins. T-pieces, scars, and flanges to special builds to accommodate challenging on-site requirements. We pride ourselves on an all-in-one solution and can manufacture GRP manholes to complete the pipeline with one material. These manholes are custom made to suit the environment and depth requirements. To ensure that we continue to provide a quality product, we test all our raw materials when they arrive at the factory before they are even offloaded. This is conducted on the resin, sand, and glass. We work very close to our suppliers and also receive the supply certificate of analysis. All raw materials are inspected before they are sent to the manufacturing floor. Mechanical tests are conducted on the pipes twice a day, and these tests are stiffness and ring bending, actual load capacity, hoop load capacity, and LOI, loss of ignition testing. During the loss of ignition test, small blocks of pipe are cut from a sample piece taken off the product line. The sample is then weighed and recorded. The sample is then placed in the oven and baked to 610 degrees Celsius. This burns up the resin and we're left with the remains of glass and sand. The hoop roving glass and the chopped glass is then separated into two dishes and we're left with the sand. These samples are then weighed and checked against the original design to ensure that the pipes are being produced according to the design specification. The sand is also filtered through a sifting machine to ensure that all the glass particles are removed. We conduct two tensile tests on the pipe. The first one is the hoop tensile. Here, we take a ring sample or slice of the pipe and pull the pipe outward to test the amount of Newton per millimeter it will take to break the pipe. This is then recorded and sampled against the original specification. The second tensile test is taken in the longitudinal section of the pipe and once again pulled until it breaks to the test newtons per millimeter until the pipe gives away, and is then recorded and compared to the original design specification. Lastly, we test the deflection of the pipe. We place the pipe under pressure from the top and bottom of the pipe until it reaches a maximum of 20% deflection of the original diameter. This is being tested at 2 mm per minute. The pipe is then sprayed with a penetrating dye to see if there are any visible cracks and breaks in the lining. The original design specification allows for no separation or cracks within the layers. Flowtite GRP pipes are compliant to SAS 1748 Part 1, and we are also certified to ISO 9001-2018 for our quality management systems. You are welcome to view our production facility in person when you are in Johannesburg again. Thank you for joining us on the tour of our production facility.